looking at simultaneous equations. So there are two terms that you need to focus on in this one. I'm sure you're quite familiar with the term equation. And we know that when you're talking about an equation, it's a case where you've got mainly an equal sign. Because you need to know that there's a difference between an expression and an equation. So for starters, this is what you are quite familiar with. And then the word simultaneous simply means when two things are happening at the same time. So simultaneous simply means two things happening at the same time. So two things occurring or happening at the same time. At the same time. So in other words, at the same time. So when you combine the two, simultaneous equations is basically when you want to find the solutions that are the same for both equation 1 and equation 2. So of course in higher mathematics you can have cases where you can have at least 3 or even 4 equations that you can solve simultaneously. But for our scope or for our level, we'll only be focusing on 2 equations. So maybe let's start with a simple equation. So recall, when you're solving an equation, for instance, you are given y is equals to, let's say 4x plus 2. So this is just a simple linear equation. So we know that when you are solving a case like this, let's say they ask you to find x. So find the x when y is equals to 2, for instance. So we're starting from something that you were looking at or that you may have come across in simple linear equations where you just have one equation. So what you do in this case, since y is equals to 2, you would simply substitute where there is 2, rather where there is y, you put 2, and therefore 4x plus 2. And then solve this to find x. So what do you do? 2 is equals to 4x plus 2.
Minus 2.
So subtract 2 both sides. So 0 is equals to 4x divided by 4. Therefore, x is equals to 0. So this is where you are just given one simple equation that you just want to solve. But then, since we are looking at simultaneous equations, we are now looking at a case where, let's say we've got two equations. Let's say, in addition to the y is equals to 4x plus 2, we have a second equation, which is, let's say, y is equals to 3x plus 4. You're asked to solve. So normally they will ask you to solve these simultaneous equations. What this basically means is that you find a solution of x and y that when substituted into the second equation, you still have the same values. In other words, what is the solution that is equivalent in equation 1 and equation 2? Such that when you have the value of x and y, when you plug it into the first equation, it will give you the same value. And when you plug it into the second equation, it will give you the same value on both sides of the equation. So that's what we mean when we're solving simultaneous equations. Now, we'll solve this one, of course, but I have to highlight how many methods, or what are the methods that are there when it comes to solving simultaneous equations. So there are 3 methods. But for today, we'll look at the last 2. So the first one is called the graphical method. The graphical method. And in this particular method, just to highlight, you will need to recall coordinates or linear graphs. Then the second method is called the substitution substitution method. Now this is one method that is particularly a problem for most learners. So I'll start by demonstrating this one. And of course, I'll give you some clues on how to determine which method you should use, so that will be easily accessible to get the answers. And then the last one, of course, we have what you call the elimination method. So what you notice is that all these three methods are actually named according to what you are going to do when you are solving them. So in a graphical method, it simply means you'll be drawing graphs and finding the solutions for both equations. And then the substitution method, that means you'll be doing a substitution. You'll notice that in fact here, we did a substitution of the value in the place of y, we put 2, and then we were able to solve for x. And then the elimination also, that means we'll be eliminating one variable to solve the other. So let's get into the details now. So of course, starting with substitution. So I will show a couple of cases in which you can use the substitution method. So substitution method. So I will start by using this one, or to solve that one as our example. So you notice here, or maybe let me first write a few notes. So in this method, we are just substitute one variable in the place of another. In the place say, since the variable y is equivalent to 4x plus 2 and y is equivalent to 3x plus 4, shows in the place of y, instead of putting y, we're going to put the variable that is on the right hand side. Why are we doing that? It is because this variable is equivalent to y. So in the place of y in the second equation, we are going to put 4x plus 2. So this gives us a new equation, which would be 4x plus 2 is equals to 3x plus 4. I will give you a second example, which I'm sure it will bring more clarity to this. So you'll notice that in the place of y now, we've put this value, this expression, which is 4x plus 2, in the place of y. So this makes one variable, because it is difficult. You can't solve this equation because we've got two unknowns. You can't solve this single equation alone. You also can't solve this single equation alone. So you need to find a way of combining it. And that is where we apply this substitution method. So now notice that actually we have now one variable which we can solve easily. Now, I always say when I advise learners to solve cases like this, uthatha le value lencane uyimise kule nkulu, noma-ke uthatha lo mncane umixe kulo mdzala, ngeke uthathe lo mdzala umixe kulo mncane. So in other words, instead of saying 4x minus 3x, that will give you a negative. So you are going to take the small value, which is 3x, to the other side. In other words, subtract 3x both sides. You may ask, why are we doing this? This is to help us to get a positive value of the variable that we want. So in this case, it's value x, so it is easy to see a positive, rather than having to divide by a negative. So therefore, this will give us x plus 2 is equals to 4. So how did we get that? It's 3x, some subtractor both sides, plus negative 4x minus 3x, which is x, tatabo, x labang 4, tatabo 3x, and then this 2 is still there. So in this case now, we have no choice but to subtract this 2, so that the value of x is equals to 2. So this is the value of x. So I've actually found the value of x, and now we want to find the value of y. So after I found the value of x, you are going to choose either equation 1 or equation 2, and then where there is x, you substitute for the value of 2. So y is equals to 4x plus 2. So where there is x, I'm going to put 2. So that the value of y is 4 times 2 is 8 plus 2 is 10. So this will be the value of y. So you will notice that once you find one of the variables, it becomes easy to get the second, because you will simply substitute that variable, that value, in either the first or the second equation to get the second variable. Right. Now, I want to show a second example in which nakhona sitawusebenzisa a substitution method. Now, this one, it will make sense, or it will make it much more clearer, because Lana, you could argue that you still get the same answer, because it's never y. But what I want to show now, let's say we have y is equals to 2x plus 1. And then we have 3y plus 4 is equals to 5x. Now this one is a perfect one. This is equation 1. This is equation 2. I want to show you why it is important to know the exact understanding of what substitution means. So notice in equation 1, this is where I'm actually going to give you a tip on how to identify which method to use. So here's the tip. When you look at both equations, once you find one equation that has one variable as the subject, that's one, and in that variable, which is the subject, once the variable you have a coefficient of 1, then you should use a substitution. I will explain why. Now, what do I mean? It's the equation here. What's the subject now? Y is equals to 2x plus 1. Y is the subject. What's the coefficient of y? The coefficient is the number that's on the left-hand side of a variable. X, 3x, the coefficient in 3. 4x, the coefficient in 4. 5y, the coefficient is 5. So in this case, the coefficient of y is 1. So the reason kutawuba lula ukuthi ngisebenzise substitution la, look at the second equation. I've got 3y plus 4 is equals to 5x. The coefficient of 3y is 3. The coefficient of 5x is 5. This is a constant. It doesn't have a coefficient. So once one of the equations has a variable that is a subject and that subject has a coefficient of 1, it makes it easy because la y is equals to 2x plus 1. Y corner in the second equation, I'm going to put 2x is 1. Because this is true, this is mathematically true or correct. Because when you say y is equals to 2x plus 1, y corner, faka 2x plus 1, because y ubani 2x plus 1. That's what it means. So you notice that we will form a new equation. No 3 Laura so only coefficient. We will maintain no 3 as a coefficient, and then we will have 2x plus 1 in brackets. I'm writing it in red because I want to show what I've done. Then notice we say your 4 also corner, and then we still have 5x on the right hand side. So if you think about this, this almost looks like I've actually taken the variable and put it into the second one to form one equation. In a way, I've actually combined the two to form one equation, but using a method called substitution. So I can then, because this is now, the first thing that you are noticing, this is a single equation, which is a linear equation. Secondly, there is now only one variable that I need to solve. I've got the value of x, x. So which means it's a glue. I just need to combine, solve this. So what is 3 times 2x? Notice this is a single bracket. So meaning this scalar will multiply each and every variable inside. So 3 times 2x
6x.
Is 6x plus 3 times positive 1 is positive 3. And I still have the positive 4 now equal to 5x. Now, of course, collect like terms, 6x plus 7 is equals to 5x. Now remember again, I cannot stress this enough. You always take the small value to the bigger value. Because now after 6 will let give you a negative x, which you'll have to divide by negative 1. So to avoid that, I can in fact remove the constant minus 7. I will have 6x is equals to 5x minus 7. And then I will have no choice but to subtract. I've got 6x is equals to 5x minus 7. What's my next step?
Minus 5x.
Exactly, minus 5x both sides. So I will now have 6x minus 5x is the same as saying 6 over x to total 5. So this is quite easy. And then on the right I have negative 7. So this is the answer. X is equals to negative 7. Then of course, you are not done. You need to find the value of y. Again, another tip to give you here. To find the next variable, it will always be easy to still use the variable, even a coefficient, even a subject, then a coefficient y, because it makes it easy. But still, you can still get the same answer using the second equation. It's just that this one is much more efficient, and it will give me the answer in less than 15 seconds. So y is equals to 2x plus 1. So where there is x, I will put negative 7. So to show that I've actually substituted the negative 7 where we've got x. So y is equals to 2 times negative 7,
Negative 14.
negative 14 plus 1, and the answer is negative
Negative 13.
negative 13. So these are the answers that I had. Y is equals to negative 13 and x is equals to negative 7. So this is how we use substitution. And of course, I want you to also remember that always when you are solving simultaneous equations, you will have two answers. So in this case, x is equals to negative 7 and y is equals to negative 13. You will always have two answers, one value of x and one value of y. Right. Now, sure this one is much clearer. I want us to move on to the second. So notice that I've actually demonstrated two cases of solving simultaneous equations using the substitution method. I now want us to do the elimination. The elimination is actually the easiest of all the three, or rather of all the last two, because the first one is always the graphical one. You can always get away by just drawing the linear graphs and see where they intersect. Now, elimination. The elimination method is also another, or in fact is the last one of the three methods of solving simultaneous equations. And I'm going to highlight and demonstrate 3 steps on how we solve simultaneous equations using the elimination. And then I'm going to show some cases, a couple or 3 that I can demonstrate in case where you would it would be efficient to use the elimination method. And of course, I'll give you a tip on how to identify which method to use. So, step 1, because there are 3 steps. So step 1 in solving simultaneous equations using the elimination method, you have to choose the variable that you want to eliminate. So always choose the variable. First, choose the variable to eliminate. Choose the variable to eliminate. So normally we'll have cases like x and y, so you can choose x or y, but sometimes you can have even a or b. And then the second step, step 2. The second step has to do with ensuring that the chosen variables have the same coefficient in both equations. Or let's just write, make the coefficients in both equations the same, or to be the same. In other words, the coefficients of the chosen variable. So make the coefficients in both equations the same. Now in brackets you can say in chosen variable. Chosen variable. So that it makes sense, because we are still focusing on the variable that we've chosen to eliminate. So I say you make the coefficients in both equations in that chosen variable to be exactly the same. You will see how we do that. And then finally, step 3. If the signs of the coefficients So we're still talking about the coefficients that were made to be the same. If the signs of the coefficients are the same, what you do is you subtract. If they are different, add. So this is important. If the coefficients that you have made the same are the signs of the coefficients that you have made the same are the same, you should subtract. If the signs of the coefficients are different, you add. So let's look at some examples. So let's look at the first case. Let's call it case 1. Now case 1 will always be the easiest. Let's say we've got y is equals to 2x plus 1 and y is equals to 4x plus 2. Now, if I may ask, by looking at this, because we're saying there are 3 steps. The first step, it is to choose the variable you want to eliminate. The second step, you make the coefficients of the chosen variable to be the same. And then lastly, if the signs of those coefficients are the same, you subtract, and if they are different, you add. So if I may ask, which variable is easy to eliminate now? X or y?
Y.
Y, exactly. So y is easy to eliminate. Why? Because of already, number one, these variables are already exactly the same. In fact, they are literally exactly the same in the sense that the signs and even the coefficients. So which means that what do we do? Do we subtract or we add?
Subtract.
Yes, we separate because the coefficients of the chosen variable, this is a positive and a positive, so it's the same. So we separate. Y is eliminated. Now, please make sure that you consider this whenever you are subtracting or adding. Yonke item ihamba nesign yakho. So ngikuxoxile. This is positive 2x minus positive 4x, which gives us negative 2x. This is positive 1 minus positive 2. This would be very important, especially when we are negative now. You would see something interesting. So this is positive 1 minus positive 2, which gives us 1 minus 2.
1 minus 2, negative 5.
Negative 1. So this tells us that in fact 0 is equal to negative 2x minus 1. So we can take this to the other side so that it becomes positive, and then we've got negative 1 divided by 2. So x is equal to negative half. X is equal to negative half. And then of course, once you get this answer, then just like we did the substitution, cycloidal value here, we then just choose any variable now. So it's easy for me to use y is equal to 2x plus 1. And then where there is x, I'm going to put negative half. And then plus 1. So you'll notice that 2 multiplied by half, which is negative, you get what? Negative 2 times negative half, you should get negative 1. Because these 2 cancels that, when 1 times negative 1 is negative 1. Plus 1. The answer is y is equal to 0. So x is equal to negative half. And y is equal to 0. So this is case 1. Now, Case 2. Now, I'll leave that there because I want you to notice the difference. Case 2. Let's say we have y is equals to 2x plus 1. And then we've got 2y is equals to 3x plus 6. Now this one is interesting. Again, I want you to notice something. Which coefficient is easy to eliminate now? Remember, first step, you choose the variable to eliminate. It's always better to choose the most efficient one. By efficient in this case, I mean, once you've chosen that variable, it should be easy to eliminate. X or Y?
Y.
Y again. Why? Because we're not supposed to use guesswork. Why is Y easy to eliminate? Or maybe to help you in getting the answer, what would be the next step now? Remember, step 2 would say make the coefficients in both equations. That is the coefficient of the variable that you have chosen to be the same. So now we've got y, we've got 2y. In other words, how can we make low y with having 2y?
Longitude times 2 now plus times 1.
So longitude, in fact, in this second case, I think the method is to multiply by the factors that will give you the least multiple or the lowest common multiple. But I will explain that in the third case. In this case, we just multiply the first equation by 2. You don't need to multiply by 1 because it will always be like that. So which means equation 1 will become 2y equals to, notice that this value is going to multiply all the terms, both sides of the equation. So 2y is equals to 4x plus 2. And then the second equation is still the same. 2y is equals to 3x plus 6. And then since we want to eliminate y, the next step to focus on now is, are the signs of the coefficient that we've chosen the same? If they are the same, what do? Subtract. If they are different, we add. So in this case, they are the same. So we subtract. So 2y minus 2y is 0. Keep getting these values. Then this will be 4x minus 3x is x. 2 minus 6,
-4.
-4. And therefore, add 4 both sides. So x is equals to 4. Quite easy. So the value of x is equals to 4. And then of course, it is easy to choose equation 1. Y is equals to 2x plus 1. And then where there is x, I put 4. So that when I add 1, this would be 8 plus 1, which is equals to
9.
9. So I've got the value of x, which is 4, and the value of y is y is positive 9. So notice the difference between case 1 and case 2. In case 1, we're having just both coefficients are the same. In case 2, we've got one variable that has a coefficient of 1 and the other is not. So it has a different one. Now the last case is the one that is particularly a challenge for a number of students. Case 3. So case 3 is is a case whereby, let me use different variables now, let's say A and B. So let's say we've got 3A plus 2B is equals to negative 4. And then we've got 2A plus 5B is equals to 10. Or let's even say minus. I haven't used the negative signs. Now, case 3, you are scoring for choice here in the sense that whether you choose to eliminate variable A or you choose to eliminate the variable B, you will still use the same procedure. So in this case, if I choose to eliminate A, for instance, this is where I need to find the LCM. So what's the LCM of the coefficients that are given to me? In this case, 3 and 2. So in a case like this, you're going to take those factors. Well, in fact, they are factors, but also they are multiples. So these should be multiples that would give you the least number. In other words, there should be the lowest common multiple of those two factors. So in this case, we've got 3 and 2. What's the LCM, or the lowest common multiple of 3 and 2? So that's one way of explaining it. Another way of explaining it is you simply swap these factors. What do I mean by that? You simply swap the factors in the sense that the 2 will multiply on top and the 3 will multiply below. So notice that you still get the value of 6. So in other words, again, 2 will multiply the first equation and 3 will multiply the bottom. The reason I'm explaining this LCM is because this will give you the least and the most substituted and simplified value of the answer, excuse me. Now, so you notice that equation 1 will become, so notice the 2 multiplies here and there, or both sides of the equation. So this would be 6A plus 4B is equals to negative 8. Because it's 2 times 3A, 2 times 2B, and 2 times negative 4. That's our first equation. The second equation would be, again, this 3 multiplies all the terms, both sides of the equation. So 3 times 2A is what? 6A. And 3 times negative 5B, negative 15B. And then 3 times 10, you get 30. Now, since the variable that you have chosen to eliminate is in fact A, so you notice that what makes this easy again is that not only are the coefficients the same, but they are also having the signs the same. Lana, this is positive 6A and this is positive 6A as well. So remember, our step 3 said if the answers, or rather if the coefficients are the same, what do we do? Subtract. So 6A minus 6A gives us a 0, so it's already eliminated. This is where it gets interesting. This is not 4A minus 15B. But this is 4B minus negative 15B, which gives us 19. Because a negative following another negative gives a positive. And then this also means it is negative 8 minus 38. So negative 8 minus 38, it's more like saying 30 plus 8 and just putting a negative. So negative 8 minus 30 is negative 38. Then divide by 19, divide by 19. you notice that b is equals to negative 2. Is that so?
Yes.
So b is equals to negative 2. And now, since we have the value of b, I can find the value of a. So, for interest's sake, let me choose the second equation. So, 2a minus 5b is equals to 10. So, where there is b, I'm going to put negative 2. So I'm highlighting this so that I show what's happening. So this would be 2a, negative 5 times negative 2.
Negative 5 times negative 2.
Mm-hmm.
It's 10.
Positive 10 equal to 10. So subtract 10 both sides. 2a is equals to 0 divided by 2. So a is equals to 0. So the value of a is negative 2 and the value of b, rather the value of a is 0 and the value of b is negative 2. So this is how we solve simultaneous equations using the last two methods that include substitution and elimination method. So again, just to give you a rundown on the tips, whenever you are given a case where the variables are the same, you should always use the elimination. And again, once you always have a case, like case number 3, where the coefficients of the variables are not the same. So I'm basically talking about the coefficients of the variables. You should always use elimination. But case 2, you'll notice that case 2, you could have used the substitution. In a case where once you always have a subject of the formula, and that subject having a coefficient of 1, you should always consider a substitution. That would be the easiest way of getting the answer. Otherwise, this is how we solve simultaneous equations. And of course, if we do more practice on this, it will be a piece of cake. So this was our lesson for today, and next time we'll move on and look at another interesting topic in mathematics. Cheers for today.